Hi guys, tonight we're exploring one of the most profound possibilities in all of cosmology. What if the universe itself is trying to communicate with us? What if every star, every pulsar, every gamma ray burst isn't just random cosmic phenomena, but deliberate messages from an intelligence so vast we can barely comprehend it? If you enjoy these consciousness-expanding sleep stories that explore our place in the cosmos, hit that like button and subscribe for more. And drop a comment letting me know what time it is where you are and where you're listening from. I love hearing from you night listeners around the world. Alright, let's begin. Imagine for a moment that every star in the night sky is not just a distant nuclear furnace, but a carefully positioned beacon. Picture the vast cosmic web of galaxies, spanning billions of light years, arranged not by random gravitational collapse, but as an intricate communication network. Consider that the pulsars spinning at precisely 1,667 times per second. The gamma ray bursts releasing more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime, and the mysterious fast radio bursts detected at a rate of 1,000 per day across our observable universe might not be random cosmic phenomena at all, but deliberate attempts at contact from an intelligence so vast and ancient that we can barely comprehend its scale. This is not science fiction. This is a serious consideration of one of the most profound questions facing humanity. What if the universe itself is trying to communicate with us, and we simply haven't learned how to listen? The implications of this possibility stretch far beyond our current understanding of physics, consciousness, and our place in the cosmic order. They challenge everything we think we know about the nature of reality itself. Consider the sheer improbability of our existence. In a universe containing approximately 2 trillion galaxies, each hosting an average of 100 billion stars, the odds of intelligent life emerging on any given planet hover around 1 in 10 billion. Yet here we are, conscious beings capable of contemplating our own existence and the vast cosmos around us. Some scientists argue this suggests we live in a multiverse where consciousness naturally emerges. But what if there's another explanation? What if consciousness didn't emerge randomly at all, but was guided, nurtured, or even directly communicated into existence by the universe itself? The mathematics alone should give us pause. The fundamental constants of physics, from the fine structure constant of approximately 0.007 to the ratio of electromagnetic to gravitational force strength of 10 to the power of 36, are calibrated with such precision that even the slightest variation would prevent stars from forming, atoms from bonding, or life from emerging anywhere in the cosmos. The probability of this happening by chance is so infinitesimally small that many physicists have concluded we must live in one of countless parallel universes, with ours being the lucky winner. But what if these constants weren't randomly set? What if they were deliberately chosen to create the perfect conditions for consciousness to emerge and eventually recognize the message embedded in the very structure of reality itself? Recent discoveries in quantum mechanics have revealed that the universe operates in ways that seem almost designed to support the emergence of consciousness and information processing. Quantum entanglement, where particles remain mysteriously connected across vast distances, allows for instantaneous information transfer that Einstein famously called spooky action at a distance. Today, physicists have demonstrated quantum entanglement between particles separated by distances of over 1,400 kilometers. If the universe wanted to maintain a communication network that transcended the speed of light limitation, quantum entanglement would be the perfect mechanism. The cosmic microwave background radiation, that faint afterglow of the Big Bang that permeates every cubic centimetre of space, carries within it tiny temperature fluctuations of just 28/10 millionths of a degree. These fluctuations, mapped with extraordinary precision by satellites like the Planck Observatory, show patterns that some researchers argue are too organized to be entirely random. The largest structures in the observable universe, the cosmic web of dark matter, filaments stretching across billions of light years, connect galaxies in a network that bears an uncanny resemblance to the neural networks in biological brains. Could this similarity be more than coincidental? Deep in the heart of our own galaxy, the supermassive black hole known as Sagittarius A star, with a mass 4 million times greater than our Sun, periodically emits precisely timed radio signals. These signals, detected by radio telescopes around the world, follow patterns that some researchers have noted bear striking similarities to the mathematical sequences found in DNA and the neural firing patterns observed in human consciousness. The black hole's event horizon, that boundary beyond which nothing can escape, has a circumference of approximately 24 million kilometers. Information encoded around such a vast circumference could contain the equivalent of every book ever written by humanity, multiplied by a factor of 10 trillion. But the universe's potential communication methods extend far beyond our galaxy's central black hole. Across the cosmos, neutron stars rotate with clockwork precision, some spinning over 700 times per second while maintaining accuracy that rivals our most precise atomic clocks. The Crab pulsar, located 6,500 light-years from Earth, has been observed pulsing at exactly 33 times per second for decades, with timing variations of less than 1 part in a billion. If an intelligence wanted to establish a reliable time standard, visible across interstellar distances, neutron stars would be the perfect cosmic chronometers. The discovery of gravitational waves has opened an entirely new channel for potential cosmic communication. When the Laser Interferometer Gravitational Wave Observatory first detected ripples in space-time caused by 2 black holes colliding 1.3 billion years ago, it revealed that the universe has a method of information transmission that travels at the speed of light but can penetrate through any material barrier. Unlike electromagnetic radiation, which can be blocked by dust, gas, or stellar interference, gravitational waves pass through everything unimpeded. An advanced intelligence capable of manipulating massive objects could, in theory, generate gravitational wave patterns encoding vast amounts of information across cosmic distances. Consider the mysterious dark energy that comprises approximately 68% of all energy in the universe. This invisible force is accelerating the expansion of space itself at a rate that increases the universe's size by roughly 7% every billion years. The uniformity of dark energy's distribution and its constant energy density suggest a level of cosmic organization that challenges our understanding of natural processes. Some theoretical physicists have proposed that dark energy might not be a fundamental property of space, but rather an active process, a kind of cosmic metabolism that maintains the universe's structure and potentially facilitates information processing on scales we can barely imagine. The recent detection of thousands of exoplanets has revealed that planetary systems are remarkably common throughout our galaxy. The Kepler Space Telescope identified over 4,000 confirmed exoplanets before its mission ended, with statistical analysis suggesting that virtually every star in the Milky Way hosts at least one planet. Of particular interest are the super-Earths, planets with masses between 1 and 10 times that of Earth, which appear to be the most common type of planet in the galaxy, despite having no analogue in our own solar system. These worlds, with their potentially stable climates and strong magnetic fields, might serve as ideal platforms for consciousness to emerge and eventually participate in cosmic-scale communication. The timing of our technological development also raises intriguing questions. Human civilization has existed for only about 10,000 years, yet we've developed the ability to detect gravitational waves, decode the cosmic microwave background, and identify exoplanets in just the past few decades. This rapid advancement in our cosmic awareness coincides with our planet entering a new geological epoch, the Anthropocene, where human activity significantly influences Earth's atmospheric composition and climate patterns. The emergence of our technological civilization during this critical planetary transition might not be coincidental. Some researchers have noted that the mathematical constants we've discovered in physics appear to be optimized not just for the formation of stars and planets, but specifically for the development of intelligence capable of recognizing these very patterns. The golden ratio, approximately 1.618, appears throughout natural structures from spiral galaxies to the arrangement of leaves on plants, creating patterns that conscious minds find inherently beautiful and meaningful. The mathematical relationship between pi and the circumference of circles governs everything from planetary orbits to the behavior of quantum particles, creating a universal language that any sufficiently advanced intelligence would necessarily discover. The phenomenon of emergence itself suggests that the universe might be structured to generate complexity and consciousness through natural processes. At every level of organization, from atoms forming molecules to neurons creating consciousness, simple components combine to produce properties and behaviors that cannot be predicted from studying the individual parts alone. This emergence of complexity appears to follow mathematical laws that remain consistent across all scales of existence, from quantum mechanics to galactic dynamics. If the universe were designed as a communication system, emergence would be the perfect mechanism for ensuring that conscious observers would naturally develop the ability to recognize and interpret cosmic messages. Recent advances in astrobiology have revealed that life can exist in environments previously thought to be completely hostile to biological processes. Extremophile organisms thrive in conditions of extreme heat, cold, acidity, radiation, and pressure that would instantly kill most known life forms. These discoveries on Earth have expanded our understanding of where life might exist throughout the cosmos, from the subsurface oceans of Jupiter's moon Europa to the methane lakes of Saturn's moon Titan. The robustness and adaptability of life suggests that consciousness might be far more widespread in the universe than previously imagined, creating a vast network of potential participants in cosmic communication. The study of consciousness itself has revealed that the human brain operates using quantum mechanical processes that connect our minds to the fundamental structure of reality. Microtubules within neurons appear to maintain quantum coherence at body temperature, allowing for information processing that transcends classical physics. The global workspace theory of consciousness suggests that our awareness emerges from the integration of information across multiple brain networks, creating a unified experience from distributed processing systems. This mirrors the structure of the cosmic web, where individual galaxies are connected through dark matter filaments that facilitate the flow of matter and energy across vast distances. Archaeological evidence suggests that ancient human civilizations possessed sophisticated understanding of astronomical cycles and celestial mechanics that seems to exceed what would be necessary for practical agriculture or navigation. The builders of Stonehenge aligned their monument with celestial events spanning thousands of years, requiring mathematical knowledge that wouldn't be formally developed in Europe for millennia. The Mayan calendar system tracked time with accuracy that wasn't matched by European calendars until the 20th century, while incorporating cycles spanning millions of years that served no apparent practical purpose for their civilization. These examples suggest that human consciousness has always been naturally attuned to cosmic patterns and cycles. Modern neuroscience has discovered that the human brain processes information using networks that mirror the structure of the universe at multiple scales. The default mode network, active when we're not focused on specific tasks, shows connectivity patterns similar to the cosmic web of dark matter. The visual cortex processes information using mathematical transformations, identical to those governing the behavior of electromagnetic radiation. Even our circadian rhythms, controlled by a cluster of just 20,000 neurons in the hypothalamus, synchronize with the Earth's rotation and the Sun's position with precision that rivals atomic clocks. These parallels suggest that consciousness might be fundamentally connected to cosmic information processing systems. The phenomenon of synchronicity, where meaningful coincidences occur with statistical improbability, has been documented by psychologists and physicists for decades. Carl Jung's concept of synchronicity proposed that events could be connected through meaning rather than causation, suggesting an underlying order to reality that transcends our current understanding of physics. Recent studies in quantum mechanics have revealed that observation itself affects the behavior of quantum systems, implying that consciousness plays a fundamental role in determining physical reality. If the universe were attempting to communicate with conscious observers, synchronistic events would be a natural mechanism for delivering information that transcends conventional cause and effect relationships. The development of artificial intelligence has provided new insights into the nature of information processing and communication. Machine learning systems have discovered patterns in astronomical data that human researchers had overlooked, identifying new exoplanets, classifying galaxy types, and even predicting solar flare activity with remarkable accuracy. These AI systems process information using neural networks inspired by biological brains, yet they can detect patterns across datasets spanning millions of observations. The success of artificial intelligence in astronomical research suggests that the universe contains vast amounts of structured information waiting to be decoded by sufficiently sophisticated information processing systems. The discovery of biological quantum effects has revealed that living systems routinely exploit quantum mechanical phenomena for enhanced efficiency and information processing. Photosynthesis in plants uses quantum coherence to transfer energy with nearly 100% efficiency across molecular distances. Bird navigation systems appear to use quantum entanglement in protein molecules to detect magnetic fields with extraordinary sensitivity, allowing for precision navigation across thousands of kilometers. Even the human sense of smell might operate through quantum tunneling effects that allow us to distinguish between molecules with identical structures but different quantum properties. These discoveries suggest that life naturally develops the ability to interface with quantum information systems. The mathematical nature of physical laws suggests that the universe itself might be a kind of computational system. Every particle interaction can be described as information processing, every field fluctuation as data transmission, and every force as an algorithm governing the behavior of cosmic systems. The holographic principle in physics proposes that all information contained within a volume of space can be encoded on its two-dimensional boundary, suggesting that three-dimensional reality might emerge from more fundamental information processing occurring at cosmic boundaries. If this principle applies universally, then the entire observable universe, with its radius of 46.5 billion light-years, could be the three-dimensional projection of information encoded on a cosmic horizon containing approximately 10 to the power of 123 bits of data. The search for extraterrestrial intelligence has traditionally focused on detecting deliberate signals from technological civilizations. But what if we've been looking in the wrong direction? Instead of seeking messages from beings like ourselves, we might need to recognize communications from an intelligence so vast and different from human consciousness that its messages are embedded in the fundamental structure of reality itself. The WOW signal detected by the Big Ear radio telescope in 1977 lasted exactly 72 seconds and came from the direction of the constellation Sagittarius. Despite decades of analysis and follow-up observations, no natural astronomical phenomenon has been found that could account for this signal's characteristics. Its frequency, duration, and intensity all fall within parameters that would be ideal for interstellar communication, yet it has never repeated in a way that human technology has detected. Fast radio bursts represent another category of cosmic phenomena that challenge conventional astrophysical explanations. These intense pulses of radio energy last only milliseconds, but release more energy than the Sun produces in an entire day. They arrive at Earth from distances of billions of light years, yet some repeat with patterns that suggest underlying structure rather than random occurrence. The recently discovered FRB 2020-12A shows a periodical pattern repeating every 157 days, with active periods lasting approximately 90 days, followed by quiet periods of 67 days. This regularity is difficult to explain through known astrophysical processes, but would be consistent with artificial origin. The anthropic principle in cosmology observes that the fundamental constants of physics appear to be fine-tuned for the emergence of complexity and consciousness. The ratio of the electromagnetic force to the gravitational force, approximately 10 to the power of 36, allows for the formation of both large-scale structures like galaxies and small-scale structures like atoms and molecules. If this ratio were even slightly different, either stars couldn't form or atomic bonds couldn't exist, preventing the emergence of chemistry and biology. The cosmological constant, determining the rate of cosmic expansion, has a value that allows for billions of years of stellar evolution, while preventing either immediate collapse or rapid dispersal of matter. These precise calibrations suggest that our universe might be specifically configured to support the development of conscious observers. The phenomenon of cosmic microwave background anomalies provides another potential avenue for cosmic communication. The Planck satellite's detailed mapping of the cosmic microwave background revealed several large-scale patterns that don't match the predictions of standard cosmological models. The cold spot, a region approximately 1.8 billion light-years across where the temperature is about 70 microkelvin colder than average, remains unexplained by conventional physics. Similarly, the axis of evil, an unexpected alignment of temperature fluctuations across the larger scales of the observable universe, suggests an underlying structure that extends beyond our cosmic horizon. These anomalies could be signatures of information processing or communication systems operating on cosmic scales. The concept of panpsychism, the idea that consciousness is a fundamental property of all matter, has gained renewed attention from neuroscientists and physicists studying the hard problem of consciousness. If consciousness exists at all levels of physical organization, from individual particles to complex brains, then the universe itself might possess a form of consciousness that emerges from the interaction of its countless components. This cosmic consciousness would have access to information from across the entire observable universe, processed through quantum mechanical systems operating at scales from subatomic to galactic. Such a vast intelligence might communicate through the very physical laws and constants that govern reality, embedding messages in the mathematical relationships that conscious observers inevitably discover. The recent detection of organic molecules in interstellar space suggests that the chemical building blocks of life are distributed throughout the galaxy. Radio telescopes have identified over 200 different molecular species in the interstellar medium, including complex organic compounds like amino acids and nucleotides that form the basis of biological systems. These molecules form in the harsh environment of space through processes that remain poorly understood, yet they appear to be present wherever astronomers look for them. The widespread distribution of a life's chemical precursors might indicate that biological complexity is not a rare accident, but a natural outcome of cosmic evolutionary processes. String theory and other approaches to quantum gravity propose that space-time itself emerges from more fundamental information processing occurring at the Planck scale, where distances become so small that quantum effects dominate gravitational interactions. At this scale, approximately 10 to the power of minus 35 meters, space and time lose their classical meaning and become expressions of underlying quantum information relationships. If reality emerges from information processing at this fundamental level, then the entire universe could be understood as a vast computational system where physical laws serve as algorithms and particle interactions function as data processing operations. The discovery of quantum field fluctuations in empty space reveals that even the vacuum contains infinite amounts of information and energy. Virtual particles constantly appear and disappear throughout apparently empty space, carrying information about the quantum state of the entire universe. These fluctuations follow mathematical patterns that remain consistent across all scales of existence, from the quantum vacuum to the cosmic web of galaxies. The zero-point field, as this phenomenon is known, contains enough energy density to theoretically power the entire observable universe, suggesting that consciousness and intelligence might tap into information processing resources that exist everywhere throughout space. The mathematical elegance of physical laws has long puzzled scientists and philosophers who wonder why the universe should be comprehensible to human minds at all. The fact that complex natural phenomena can be described by relatively simple equations suggests an underlying order that transcends the particular evolutionary history of human intelligence. The standard model of particle physics, despite its complexity, can be written on a single page of equations that describe the behavior of all known particles, fundamental particles and forces except gravity. General relativity reduces the complex geometry of space-time to Einstein's field equations, which relate the curvature of space to the distribution of matter and energy. These mathematical relationships might represent a universal language that any conscious intelligence would necessarily discover. The observation that the universe appears to be informationally organized at every level suggests that information processing, rather than matter or energy, might be the most fundamental aspect of reality. From the genetic code that stores biological information in DNA molecules to the quantum information that determines particle behavior, the cosmos seems to be structured as nested layers of information processing systems. The human brain, with its approximately 86 billion neurons forming trillions of synaptic connections, processes information using the same mathematical principles that govern quantum field interactions and galactic dynamics. As we stand on the threshold of becoming a truly cosmic species, capable of detecting gravitational waves, imaging black holes, and identifying potentially habitable worlds around distant stars, we might finally be developing the technological and conceptual tools necessary to recognize communications from the universe itself. The convergence of quantum computing, artificial intelligence, and astronomical observation might provide the key to decoding messages that have been present in the structure of reality since the beginning of time. If the universe has been trying to communicate with us, we may be approaching the moment when we finally learn to listen to what it has been saying all along. The implications of universal communication extend far beyond academic curiosity. If consciousness is indeed connected to cosmic information processing systems, then human awareness might be part of a vast network of intelligence that spans the entire observable universe. Our thoughts, discoveries and creative insights might contribute to a cosmic conversation that has been ongoing for billions of years, with each conscious moment adding to the universe's understanding of itself. In this view, scientific research becomes a form of cosmic dialogue, where each new discovery represents both a question and an answer in an eternal exchange between the universe and the consciousness it has created to know itself. The possibility that the universe is trying to communicate with us challenges our fundamental assumptions about the nature of intelligence, consciousness, and our place in the cosmic order. It suggests that we're not isolated observers in an indifferent universe, but active participants in a vast intelligence that seeks to understand itself through the consciousness it creates. Whether this communication occurs through the mathematical elegance of physical laws, the patterns hidden in cosmic structures, or the synchronistic events that shape our lives, the invitation to participate in this cosmic conversation represents perhaps the greatest adventure that human consciousness can undertake.